Okay, welcome. Today we're going to need not only your notes, but you're going to have to open up your copy of your presentation we worked on yesterday. It was called Compositions of Transformations 2. You will submit this today, so make sure you have made a copy. You named it with your last name, first initial, and entitled it Composition of Transformation 2. And that would be step 2. Make sure you've changed the sharing to anyone with a link. And when we finish this assignment, copy the link, open a quick response form, and paste it in box 2 only. Notice it says box 2 only or no credit. I'm not going to give you credit unless you do box 2. Let's go ahead and open this up and get your notes ready. Remember, anytime during the video, if you need to pause it to keep caught back up, go ahead and do that. And if you need to re-listen to a concept, go ahead and do that. Sometimes it takes a couple times for us to make the connection. Okay, my expectation is there are times I'm going to ask you to pause the video and try some work on your own, that you do this. Do not listen to the video straight through without pausing and trying to work, because you're losing out on the practice, and practice is what we need. Okay, let's begin. All right, a little review of yesterday. These are the rules for rotation around the origin. Make sure that you have your 90 clockwise and 90 counterclockwise correct. These are the two that got confused in a couple classes yesterday. Kids were mixing them up, so go ahead and check yours. Now, if yours is correct, that means your slides on the next screen is the ones we worked on in class yesterday, are probably correct. Now, if yours is off, you're going to have to redo those slides. So let's go ahead and take a look at those. Now, if you're not done checking, make sure you pause your video now and check these. If you're done, let's go ahead and move on. Okay, so if you did yesterday's rules right, chances are you did your rotations right, unless you made a math error. If you did your rules wrong, then you're going to have to redo these. So make sure you stop the video and redo these before moving on. Okay, let's go ahead and talk about today's stuff. Our objective today is to identify glide reflections in a plane. A glide reflection is just a composition of transformations, usually a translation with a rotation or translation with a reflection. We also have to represent transformations as simple compositions of simpler transformations. One more time, represents transformations as simple compositions of simpler transformations. It simply means we're going to have multiple transformations for one problem. Let's go take a look at our composition of transformations. When two or more transformations are combined to form a new transformation, that's two or more, it'd be 3, 4, the result is called a composition of transformations. Now, this is the key part. In a composition, the first transformation produces an image. So we start with a pre-image, we do whatever it says, a reflection, rotation, or translation, and we end up with an image. And when we do the second transformation, the second transformation is performed, the rule we use is worked off the image. We don't go back to the pre-image, we go to the image it created from the first transformation. And if there's a third transformation, we go off the new image. So it's like a series of steps. Okay, you always work off the previous image. All right, the symbol for composition of transformation is an open circle. Okay, we can see there's one here, and we have some new notation to learn as well. This is actually translation with the rule of 3, 4, and this is actually reflection over the x-axis. Okay, so we're combining these two transformations within an open circle. Okay, so the key to compositions is how we read it as well. It's done in reverse. We're used to reading left from right. Now we're going to read right from left. Okay, so in other words, if I'm going to do this transformation or composition of transformation, I'm going to start with the translation first and work backwards. Translation, then reflection. Okay, key point. Translation, then reflection. Let's go take a look at the new notation. All right, you will be seeing the following notation. Here's what it means. Now I'm talking kind of fast. Remember, you can pause your video. In fact, I'd like you to pause your video now and take notes on this screen. When you're done taking notes, what R, T, and capital R represent, and all the information you need over here, go ahead and start the video and we'll talk about each one. So do that right now. Okay, now that you have your notes, let's talk about what it means. All right, so the lowercase r represents a reflection. The uppercase r represents a rotation, so we got to know the difference between the two. And the uppercase T represents a translation. So T is going to be easy to remember. T is for translation. The R's we could get mixed up. So a good way to identify which one it is look at the condition. Below each letter, there's a condition under which you have to do the transformation. So with a lowercase r, as we see over here, it says x equals -1. The uppercase r says origin 90. Okay, so looking at the conditions, this is obviously a reflection across the x equals -1 line. And this is also obviously a rotation around the origin 90 degrees. Now the translation, we have the condition is the rule. This is 3 to the right and -2 down. Okay, so how do I read this? A reflection along the x equals -1 following a translation of 3 to the right and down to 2 following rotation along 90 around the 90. Just slurred that. Let me do that again. How do I read this? A reflection across x equals -1 following a translation of 3 to the right down 2 following a rotation along the origin of 90 degrees. And the key here is following. It means it comes next. Okay, so what we're trying to say is simply, I'm going to do, let's find a good pen here. There we go. It means I'm going to start here first. And then I'm going to go to this one. So I'm going to start with the origin. I'm going to rotate this around the origin 90 degrees counterclockwise. If it was clockwise, it would say, so everything's always counter unless it says. I think I'm going to translate it. I'm going to go 3 to the positive direction, -2 down. A little delay on the machine here, sorry about that. And then lastly, I'm going to, wherever that at, or whatever this shape is at, I'm going to reflect it across the x equals -1 line. So it's done in reverse. So pause the video if you needed to kind of look this over and make sure you understand it, and then we'll move on. Okay, so how do we perform this composition of transformations? So here we already have an image and a few, pre-image and a few images for this composition we see over, let's open up the pen, we see over here. So we're going to go through this step by step and make sure we understand how it works. Work it backwards, that's how it's written. All right, so the first thing we're going to do is we're going to come over here, we're going to identify our pre-image. Our pre-image starts here, a triangle ABC, and there's our coordinates. And the first thing we're going to do is rotate it 90 degrees. So we're going to do this one first. Okay, so we're going to rotate it around the origin 90 degrees. So you come over, you've got your coordinates. We apply the rule, and when we're done, the shape is going to be over here. So we rotated it 90 degrees around the origin. Okay, so the second thing we're going to do is we're going to translate it 3 units to the right, -2 down. So let's do that. So we're going to apply our rule. Now we're not going to use the coordinates for A, B, and C. We're going to use these new coordinates here. So we're on this image, and we're going to go, let's see, 3 to the right. This is going to be the red triangle, so we're going to end up down here. So I'll pick this vertex, 3 to the right, 1, 2, 3. 2 down. So there he is. He's down here now. 3 to the right. 1, 2, 3, 2 down. Now he's on the same point as the preimage C. 3 to the right. 1, 2, 3, 1, 2. And there is our new image. It's been translated 3 to the right and 2 down. Okay, so we went like this now. 3, 2. It's getting a little busy in here. So we went 90, then we translated 3 to the right, 2 down. And lastly, we're going to do our reflection. And we're going to reflect this shape across the x equals -1 line, which is simply right here. And we know with a reflection that our coordinates, our x coordinate will be the opposite, y's don't change the same. So we're going to flip this guy along that line. So this point is 1 away, so this point's 1 away. This point is 2 away, so this point is 2 away. The last vertex is 1, 2, 3 away, so 1, 2, 3, and he ends up over here. This is our new image down in the corner. And to get to this image, it's been rotated around the origin 90 degrees, translated 3 to the right, 2 down, and then rotated across the x equals -1 line. All right, pause your video if you need it and take a look and make sure you understand this, because we're going to try some on our own. Okay, let's move on. So make sure your notes are up to date, and if you understand, move on. If not, let's re-listen to it, and maybe you'll get it the second or third time. Remember, it takes a few times sometimes to make connections. All right, so here it is. Which type of transformation, misreading it. Write the type of transformation that took place and the order in which it occurred. All right, so we're going to kind of look at this and see what they did first, what they did second, and then we're going to write the notation. So it looks like we started with a blue line, PQ, and we can tell that because the red line has P prime, Q prime, and that's how we represent the image. And the green line has Q double prime and P double prime. So that's your final image. Okay, so what did they do first? How did they go from here to here? I'd like you to pause the video and write down what they did. Okay. Now, I might have been a little bit unclear. Some of you might go, well, what do you mean what they did? I mean, is it a translation? Is it a reflection? Or is it a rotation? Those are the three we have to choose from. So if you didn't quite understand it the first time, pause the video again and identify which one of the three it is. Okay, hopefully we've understood that from PQ to P prime Q prime is nothing more than translation. It's slid up. And we don't actually have figure or numbers to write, but we'll just call it a translation. So we'll call this guy a translation. Okay, and we'll write the rule as simply XY because we don't know. We don't have a coordinate plane. We don't have the numbers in. Okay, now here's our second from P prime Q prime. What do we do to get to Q prime P prime? Okay, that appears to be a reflection. We could, if we look closely, so let's write reflection. If we look closely, we can see that the P has been reflected to P double prime. I'm sorry, P prime has been reflected to P double prime. Q has been reflected to Q double prime over the line y is equal to K. Okay, so that is a reflection. You can see okay, sorry, we had a little technical difficulty, so the video had to skip. We were talking about the reflection. So you can see this has been reflected over the line. Don't confuse it with a rotation. So we rotate, we go around the origin, and if I was rotating around the origin, depending where things would be, this what shape would not look like this. And I know it's hard to see, but we don't really have a graph here. So this is actually representing a reflection across the y is equal to k line. Okay, so proper notation will go like this. Remember, we work backwards. So the second thing we did is what we start with, and we said this is going to be a reflection across the y is equal to k line, and it's a composition, so we put our composition symbol, and then we did a translation, and that's the capital T of, we'll just go simply x, y. Okay, if you need to, pause the video, look at it, make sure you kind of understand what's going on. If you don't, remember, stop the video, listen to it again, try it a second time or a third time. Still don't get it, maybe ask a partner. And when you're ready to move on, start the video and we'll move on. Okay, moving on, we're going to now use some actual numbers. Okay, so we have a shape here, and our image is going to be the blue image, and we're going to talk about or follow the arrows and try and decide what the transformation is. Is it a rotation, a reflection, or a translation? And then we're going to write it in proper notation. Let's go ahead and start with number 1, or the blue, I should say, triangle ABC. We have our coordinates, and the first thing they do is move it to here. So I'd like you to pause the video and write down what you see. Is it a translation, rotation, or reflection? Okay. And each one of these you need to put in if it's a translation, put in the rule. If it's a rotation, show how many degrees. If it's a reflection, over which line. Let's go ahead and pause the video and see if you can figure it out. Go ahead and do that right now, please. Okay, hopefully we saw that by looking at this, we noticed the A, B, C, A prime, B prime, C prime have not changed. They haven't been moved around. A's not over here, B's not around over here, and C's not up here. So this has not been rotated, nor has it been reflected. It's the same shape, simply slid across. Okay, so let's try to figure out the rule. It looks like that we've done, let's see, sorry, pause there. The rule would be, if I started from A is shifted to the left, or right, sorry, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count those again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it looks like it's been a translation, so we'll use a T. And X has been plus 10. Now if we shift it up and down, doesn't look like it. So it looks like 10, 0. Okay, there's our translation. We slid this thing over 10. All right, I'd like you to pause the video and go from A prime, B prime, C prime to A double prime, B double prime, C double prime. Identifies it a rotation, translation, or reflection. So go ahead and do that right now. Remember, put in the rules or the lines or the degrees of rotation. Go ahead and stop it. Okay, so from going to the red to the green, this appears to be a reflection. I can tell because when I look at A is 1, 2, 3 from the x-axis, and I notice A prime is 1, 2, 3. So the x-axis is our line of symmetry, it's our line of reflection. I check B and B prime, the same thing, C and C prime. So our second transformation in our composition is a reflection across the x-axis. Started to write y. That's right. Let's try this again. X-axis. Okay, so we have our composition. It's a translation and a reflection. So remember, we start backwards. So we're going to start with a R. Here's our proper notation across the x-axis. Composition symbol and our transformation, which is 10, 0. Okay, if you didn't understand it, again, listen to it again, and we will, or listen to it again and see if you can get it. Other than that, let's kind of move on. We're almost done for my video lesson, and then you're gonna have to do the rest on your own. So let's try one. I would like you guys to do this one on your own. So pause the video, and when you're done, go ahead and check it against mine. Okay, let's see how you did. So hopefully you figured out the transformation, wrote the composition in proper notation. If you haven't, pause it again and do it. Make sure you get the notation part completed. And if you're all good, let's go ahead and go over and see what happened. Okay, so it looks like we're starting from the blue image because the red and green have the primes. So this is our pre-image. And if I look to see what's going on from the blue to the red, first thing I notice is the shape has been shifted. We're still a line, but it's been shifted. It's not a vertical, it's horizontal now. So that tells me that it wasn't a translation. Translations, the line would still be horizontal, just be slid around. It tells me it's not a reflection, because if I reflect across the Y line or any Y line, it would still be horizontal. If I reflect across the X line, it would be still, sorry, I said horizontal, still be vertical. They both would be vertical. Since it switched, this has to be a rotation. So from here to here appears to be a rotation of 90 degrees. Okay, so we have a rotation of 90 degrees. Let's start there. First thing they did, a rotation of 90 degrees, and we went in the counterclockwise position or direction. So I'm going to write counter clockwise, all one word. That's the first thing we did. Notice I'm kind of writing backwards. Okay, to go from the red to the green, what happened here? There's actually two possible things that can happen. Remember, there's more than one way we can get here. To me, this looks like a translation. It looks like everything just shifted down 1, 2, 3. So you can write translation, where our X didn't move. There's no left and right movement. And everything slid down 1, 2, 3. And that could be the composition. Some of you may recognize going, hey, that also could be a reflection. Now, couldn't we reflect this if we could find a point of or line of symmetry between the two? So let's go 1, 2, 3. Halfway is 1.5. So it's going to be hard to get the line in there. We could call that y is equal to the -1/2 line. That can also be a reflection across the y is equal to -1/2 line. So you could have rotation, composition, reflection. Oops, I apologize. This should be a capital R. My bad. All right, so make sure you fix that in your notes. Sorry, reflections are capitals. Got to learn those. Just like I have to learn those. This should be a reflection across the y is equal to the -1/2 line. So we could say both of these could be the composition. There's going to be more than one way sometimes. Your partner may get number 1, you may get number 2. Okay, and it's okay because we end up in the same spot. So, for the next few slides, I would like you to, on your own, try these out. And when you're done, remember, I would like you to submit only for credit in box number 2. Okay, so go ahead and work on your presentations. Use your notes, do the best you can. You may have to look over a few times. You can even ask your partner a little bit. But I'd like you to work on your presentation, and when you're done, submit the quick response form in box 2. You have the rest of today, and you have all of tomorrow to work on this. Okay, so no fun tonight, meaning no homework, and let's just get this done in class. But by the end of Friday, when you leave school, I need to have this done, so use your time wisely.